Hello everyone, my name is Kishan Agarwal. Today I am going to present my concept video of computer organization and architecture, and my topic is multiprocessor and multicomputer. So let's begin with our topic. Multiprocessor. Multiprocessor is a single computer that has multiprocessors. It is possible that the processor in the multiprocessor system can communicate and cooperate at various levels of solving a given problem. So the communication between the processor takes place by sending messages from one processor to another or by sharing a common memory. In other words, a multiprocessor is a computer system with two or more central processing units which share full access to common RAM. The main objective of using multiprocessor is to boost the system's execution speed, with other objectives being fault tolerance and application matching. So there are mainly two types of multiprocessors. One is called shared memory multiprocessor and the other one is called distributed memory multiprocessor. In shared multiprocessor, all the CPUs share the common memory, but in a distributed memory multiprocessor, every CPU has its own and private memory. So what are the applications of multiprocessor? As we have seen that multiprocessors are of two type, shared memory multiprocessors and distributed memory multiprocessors. Each one have their own applications. As a uniprocessor, such as single instruction single data stream, multiprocessors can be used. As a multiprocessor such as single instruction multiple data stream, that is SIMD, which is usually used for vector processing. Next is multiple series of instruction in a single perspective, such as multiple instructions single data stream, MISD, multiple instruction single data stream, which is used for describing hyperthreading or pipelined processes. Inside a single system for executing multiple individual series of instructions, that is a multiple perspective such as multi-instruction multiple data stream, MIMD. So all the four kinds of data streams can be presented using multiprocessors, that is single instruction single data stream, that is SISD, single instruction multiple data stream, SIMD, multiple instruction single data stream, multiple instruction multiple data stream. All the four can be implemented using multiprocessors. So what are the benefits of using multiprocessors? If you use a multiprocessor, the performance of the computer increases. Your work can be done easily and time also decreases. So enhanced performance, multiple applications at the same time, multitasking inside an application, high throughput and responsive, hardware sharing among CPUs. What are the characteristics of multiprocessor? So each multiprocessor has its own characteristics, such as parallel computing. It is one of the important characteristics of multiprocessor. This involves the simultaneous application of multiprocessors. These processors are developed using a single architecture to execute a common task. In general, processors are identical and they work together in such a way that the users are under the impression that they are the only users of the system. In reality, however, many users are accessing the system at the given time. This is the very important characteristic of multiprocessor. Next is distributed computing. This involves the usage of a network of processors. Each processor in this network can be considered as a computer in its own right and have the capability to solve a problem. These processors are heterogeneous, that is, in general, one task is allocated to a single processor. Next is supercomputing. This involves the usage of the fastest machines to resolve big and computational complex problems. In the past, supercomputing machines were vector computers, but at present, vector or parallel computing is accepted by most people. Next characteristic is pipelining. This is a method wherein a specific task is divided into several subtasks that must be performed in a sequence. The functional units help in performing each subtask. The units are attached serially in all the units work simultaneously. The next and the last we are going to discuss characteristic of multiprocessor is vector computing. It involves the usage of vector processors wherein operations as multiplication are divided into many steps and are then multiplied or applied to a stream of operands, that is vectors. Systolic. This is similar to pipelining, but units are not arranged in a linear order. The steps in systolic are normally small and more in number and performed in lockstep manner. This is more frequently applied in special purpose hardware such as image or signal processors. Next, moving to multi-computers. A multi-computer system is a computer system with multiple processors that are connected together to solve a problem. Each processor has its own memory and it is accessible by that particular processor, and those processors can communicate with each other via an interconnection network. As the multi-computer is capable of message passing between the processors, to it is possible to divide the task between the processors to complete the task. Hence, a multi-computer can be used for distributed computing. It is the cost-effective and easier to build a multi-computer than a multiprocessor. Multi-computers are message passing machines which apply packet switching method to exchange data. Here each processor has a private memory but no global address space, as the processor can access only its own local memory. So communication is not transparent. Here programmers have to explicitly put communication primitives in their code. Having no globally accessible memory is a drawback of multi-computers. This can be solved using the following two schemes: virtual shared memory and shared virtual memory. Virtual shared memory. Virtual shared memory is a hardware implementation. So the virtual memory system of the operating system is transparently implemented on top of VSM. So the operating system thinks it is running on a machine with a shared memory. Next is shared virtual memory is a software implementation at the operating system level, which with the hardware support from the memory management unit of the processor. If a processor address a particular memory location, the MMU, which is memory management unit, determines whether the memory pages associated with the memory access is in the local memory or not. If the page is not in the memory in a normal computer system, it is swapped in the form of the disk by operating system. But in shared virtual memory, the operating system fetches the pages from the remote node which owns that particular pages. So there are three generations of multi-computer: design choice in the past, present and future development. Intel paragon system. So first we'll discuss with design choice in the past. While selecting a processor technology, a multi-computer designer chooses low-cost medium-grain processor as a building block. Majority of parallel computers are built with standard off-the-shelf multiprocessors. Distributed memory was chosen for multi-computer rather than using shared memory, which would limit the scalability. Each processor has its own local memory. For interconnection scheme, multi-computer have message passing point-to-point direct network rather than address switching networks. For control strategy, designer of multi-computers choose the asynchronous MIMD, MPMD and SMPD operations. Caltech's Cosmic Cube is the first of the first generation multi-computers. Next is present and future development. The next generation computers evolved from medium to fine grained multi-computers using a global shared virtual memory. Second generation multi-computers are still in use at present but using better processor like i386, i860, etc. Second generation computers have developed a lot. Third generation computers are the next generation computers where VLSI implemented nodes will be used. Each node have a 14 MIPS processor with 20 megabytes per second routing channels and 16 kilobytes of RAM integrated on a single chip. The Intel Paragon system. Previously, homogeneous nodes were used to make hypercube multi-computers as all the functions were given to the host. So this limited the input output bandwidth. Thus, to solve large scale problems efficiently or with high throughput, these computers could not be used. The Intel Paragon system was designed to overcome this difficulty. It is turned the multi-computer into an application server with multi-user access in a network environment. So lastly, we'll discuss about the differences between multiprocessor and multi-computer. So multiprocessor is a system with two or more central processing units that is capable of performing multitasks, whereas multi-computer is a system with multiple processors that are attached via internet connection network to perform a computer task. A multiprocessor system is a single computer that operates with multiple CPUs, whereas a multi-computer system is a cluster of computers that operates as a singular computer. Construction of multi-computer is easier and cost-effective than a multiprocessor. In a multiprocessor system, program tends to be easier, whereas in multi-computer system, program tends to be more difficult. Multiprocessor supports parallel computing, multi-computer supports distributed computing. Thank you.